Today, we'll be exploring animation sequences in Unreal Engine, how we can import them and work with them in the sequence editor mode. While I will be covering animation sequence assets in the sequence editor in Unreal Engine, in this video, I will not go into detail on the implementation and usage of animation sequence assets in animation graphs at runtime, as that is going to be its own video that I make in the future. Animation sequences store animation data and are associated with a skeleton asset, meaning that they can be played on any skeletal mesh associated with the same skeleton asset, or any skeletal mesh that makes use of a skeleton that is compatible with the skeleton that the animation sequence is associated with. I made a video on the fundamentals of skeleton and skeletal mesh assets in Unreal Engine where I go into more detail on that subject than I will here. It's linked in the description, so I recommend you give it a watch. Animations can be imported from an FBX file that contains an animated armature. In the import window, you can either assign an existing skeleton that exists within the project files, or create a new skeleton from the armature in the FBX file if a skinned mesh is within the file as well, as the engine will then extract that data, creating a new skeletal mesh and skeleton asset that the animation will be assigned to. In the import window, there are additional controls for importing animation data that are quite useful, allowing you to control the imported frame range and sample rate of the animation sequence. Once an animation is imported, you can double-click on it in the content drawer to open it in the engine's animation sequence editor mode. This editor mode is quite similar to the skeleton and skeletal mesh editor modes that I covered in the previous video, but has some additional panels and settings specifically for dealing with animation sequence assets. In the bottom right corner, you'll find a panel where you can see a list of all compatible animation assets in the project. You can double-click on any of these assets to open them up within the animation sequence editor. From the Asset Details panel on the left side of the window, you can select between two different interpolation modes for the animation: linear and stepped. Linear interpolation will linearly ease between keyframes, creating poses that blend the two keyframes together, when the frame rate of the game and the animation being played back diverge. Stepped interpolation will continue to play the same frame until it reaches the next one, kind of locking the frame rate of the animation in without any interpolation and holding a pose per the duration of the frame determined by the animation sample rate, which is usually 30 frames per second. Additionally, you can control the speed of the animation's playback with the rate scale setting, as well as set bone and curve compression setting profiles. There are many more settings for animation sequences, and I won't be able to go into all of them in adequate detail and explanation in this video. It's much easier to instead reference the documentation for the specific setting you're interested in, so I've linked the relevant documentation in the description below, and I recommend you give it a read after you watch through the rest of this video. There are, however, two sections which I do want to cover in much more detail in this video. The first pertains to root motion. When enable root motion is set to true, the engine will process the animated motion of the root bone in the skeletal hierarchy. This is used in many locomotion-related applications, such as orientation or stride warping, or to drive movement purely with the root motion of the animations being played, as opposed to programmatically through the use of the character movement component. When root motion is enabled and being processed by the engine, the root is locked into place in the sequence editor viewport. You can also enable the force root lock setting to force the root into place without needing to enable the processing of root motion. From the Asset Details panel, you can also denote the current animation as an additive. In Unreal Engine, there are two types of animations: absolute animations and additive animations. I'll relay the explanation provided in the 5.3 engine documentation as it states the differences quite clearly. When absolute animations are set to control the same bones, each will compete and influence one another. Additive animations can circumvent this issue and have priority over their respective region, so as not to conflict with other animations. An additive animation calculates the delta, or the displacement value, from the starting position of a selected base animation and the additive animation's pose on a frame-by-frame basis. This means that the motion of an additive animation is relative to the base animation selected in the additive settings of the Asset Details panel. The delta, or offset, between the base animation and additive animation can then be applied to any pose at runtime. For example, here I have a blend space with two single-frame additive animations, one where the character leans to the left and another where the character leans to the right. Each of these animations have a single-frame animation where the character is standing upright as the base animation. I can apply this additive blend space to an animation graph at runtime with the locomotion pose as an input, allowing an additive lean to be applied to the character when turning while preserving the underlying movement. There are many uses for additive animations, and this is just one example. I plan to cover the implementation of additive animations and locomotion systems in animation graphs in much more detail in a dedicated video, as there's a lot of pretty awesome stuff that can be done. In the Asset Details panel, you can choose between 3 additive animation types, each being a different way of determining how the delta between the base and additive pose is calculated and applied at runtime. The default type is no additive, and that just means that the engine will treat the animation as an absolute one, and it won't be able to be applied as an additive animation, and all the other additive settings will be ignored. The second is local space, and this is where the offset for each bone is calculated in its parent coordinate space, meaning that the location of the parent bone serves as the origin point for the coordinate space of the offset, where the x, y, and z values and pitch, yaw, and roll values are all respectively 0. So, for example, the offset of the hand would be calculated relative to the lower arm bone, which ends at about the wrist, and so on and so forth for each bone down the chain through the entirety of the character. This method is used most often as it does a fantastic job at preserving the local, rotational, and positional offsets between bones for limbs. The other option is mesh space. This mode is used when it is important to preserve the absolute positional offset relative to the root bone of the skeleton. You can also choose how a base animation pose is chosen for the additive animation. There are 4 options, the first being to use a skeleton reference pose, the default pose of the skeleton and skeletal mesh asset being used. The next is selected animation scaled, where an entire animation sequence asset will be used, scaled to either have a faster or slower play rate so that its duration matches the duration of the additive animation. Next is selected animation frame, which will use a single specified frame from the selected animation sequence asset. Finally, we have the option to use a selected frame from the current additive animation, which will then be treated as an absolute for the calculation of the delta between the additive animation and the selected frame, which is now its base pose. The next section of the editor to cover is the timeline. Here you can create curves that can be read at runtime, place animation notifies, notify states, and sync markers. Curves can be created and keyed manually or generated through the application of animation modifier assets, which will need to be covered in their own dedicated video. Curves can then be read at runtime using the getCurveValue node in an animation graph. If an animation is contributing to the output pose of a graph and has a curve with a name that matches the name supplied in the input field for the getCurveValue node, the node will then output the float curve value associated with the frame of the animation that is currently being played. If 2 or more animations are contributing to the output pose while also implementing the curve with the same name as the one being queried in the getCurveValue node, then the comparative ratios of the animations, so how much control they have over the output pose, will be compared, and that will be used to blend the curve values together. So if, let's say, animation A has twice as much presence in the output pose as animation B, then there would kind of be a 2-to-1 blend between the curve values in the 2 animations, and all animations that contribute to the output pose that do not have the curve will be ignored. Additionally, when no animations implement the curve being queried, the node will return a value of 0 unless you use an alternate version of the node where you can provide a default value to return in the event that no animations implement the curve name being queried. Animation notifies and notify states are classes that implement overridable events that can be called and execute code. Animation notifies have an event that is called when the frame that corresponds with the placement of an animation notify on the timeline is passed as the animation is being played back. One example of the usage of animation notifies would be to play back footstep sounds, where a notify is placed in the animation when each foot hits the ground, and the code that executes within the class plays back a footstep sound at the location of the character taking the step. Animation sequences take up a range of frames in an animation, having a start frame and an end frame, and this means there are two events that are called, one when the notify state is entered into, and one when the notify state is exited from. These are good and useful for assigning certain states to animations where you have certain values that need to be set to certain things when an animation notify is entered into. Once an animation notify or animation notify state asset is created, it'll appear as an option to place into the timeline in the animation sequence editor. Finally, we have sync markers, which can be assigned names and then placed in corresponding points in animations. Most often, at least in the implementation of locomotion systems, there are two sets of sync markers used, one named for the left foot and one for the right, and each left foot is placed as the left foot hits the ground, and each right foot one is placed as the right foot hits the ground. This is done so that when multiple animations are assigned to the same sync group in an animation graph, one will become the leader and the others will become followers determined by settings set in each animation sequence node. When this occurs, all of the follower animations will be scaled so that their sync markers align with the sync markers of the leader animation, which will preserve, in the case of using sync markers for each foot with footsteps, the alignment of footsteps while blending between different locomotion animations. This is super useful for transitioning between different directional animations or between different states, such as starts to cycles or cycle to pivot or any sort of transition you have between different locomotion states where you're not certain of the timing and can't ensure that the end of one animation will align perfectly with the start of the other as the player is transitioning between the states, leading to different animations being played. Aside from creating curves, placing sync markers and notifies, you can also trim animations within the timeline by right-clicking on a frame and removing the frames that come before or after it. The last section of the animation sequence editor I want to touch on is the toolbar, located near the top of the window. Here you can re-import the animation after editing the source FBX file, apply the selected compression type for curves and the animation itself, export the animation sequence asset as an FBX file, add a key for an additive adjustment layer, create a static mesh from the current pose, or open the animation sequencer for more in-depth editing of the animation sequence through the usage of a control rig. All right, everyone, that'll be it for this video. In the next one, available now in early access to my supporters on Patreon, over at patreon.com/outcastdevschool, I'll be covering the process of creating and working with blend spaces in the engine. Finally, I want to thank all my patrons over on Patreon for their continued support, and I'll see you all in the next video.